So the question is, prove by definition that the limit as x approaches 3 of this equation or function is equals to 11. So what I want you to do in a piece of paper is basically do two absolute values. The first absolute value, make it less than delta. So delta is this funny kind of thing. And the next absolute value, make it less than epsilon. So there's my other absolute value, and I'll make it less than epsilon. Epsilon is like an E, okay? Now, in your proof on your exam when you're writing this, just say this and this is greater than 0, epsilon and delta. Okay, so you got these two things, right? Now what I want you to do is this. I want you to look for, in this first bracket, right? I want you to look at this only. X, as x approaches 3. I want you to see the opposite. So as x approaches 3, put x down, it'll always be x. So basically the formula is x minus whatever the approach is. So x minus what's the approach is 3, and it'll be forever. Okay, if this is limit x approaches 9, what will be? It'll be x minus 9. If x approaches minus 1, it'll be x minus minus 1, which is x plus 1. So x minus the limit as it approaches. Done. So my first absolute value is done, right? Now we are going to use this just now. So let's just so you can see now how these ones are like related. Okay. So whenever you're doing the less than the what is it called delta, you're using only this one over here, right? Now for the epsilon, the formula is fx minus the limit. Fx is this whole thing here, 4x minus 1. And the limit is 11. So fx minus the limit. So basically I'm saying 4x minus 1 minus 11, right? This is fx. This is the limit. So fx minus the limit, which we need, is 4x minus 1 minus 11. So you can just rewrite. So 4x minus 1, which is the f of x, minus 11. Okay. Now, to not get confused, you can simplify it now, but we're not going to simplify it now. So we're just going to put it now in brackets so you can clearly see it. So this is f of x minus the limit. So 4x minus 1 minus 11. Okay. So done. Now what you want to do always in this proof is get this over here. Start with this. Start with the epsilon, right? And then from the epsilon, you'll go to this equation. So what I mean is this. Start with the epsilon. Now let's start with the proof. So what I want you to do is copy this down, the epsilon thing, right? So it'll be 4x minus 1 minus 11 is less than epsilon. So I just copied it down, did nothing wrong. Now what I want you to do is this, right? See this over here? I need to get somehow in the brackets x minus 3. I need to look. Basically this has to be a mirror image of this, right? So I need in brackets x minus 3, the absolute value of x minus 3. Yeah. So the absolute value has to equal to somehow x minus 3. Okay, so somehow we need to change this. So just simplify, right? So this implies. So 4x minus 1 minus 11, you just remove the brackets, is what? It's minus 12. So write that. So now we just simplify because we need the brackets x minus 3. So 4x minus 12. Okay, so now that we got 4x minus 12, it's same. I mean, we just copy down the e. Alright, now how do we get to x minus 3? Look properly. We need to somehow get x2 a coefficient of 1. So, no, just look at this. This is x, this is 4x. This is 3, this is 12. So if you take out a common factor here of 4, alright, it'll make this x and this minus 3. So perfect. So to take out the common factor, you can take it out now. So it's 4 into x minus 3. So yeah, 4 into x minus 3 is less than epsilon. Okay, so now we're almost there, but the problem is not matching now the left because I still got 4 over there. So how you get rid of the 4? Take it, put it e divided by 4. That's done, right? Divide both sides by 4. So it's x minus 3, which is less than the epsilon of 4. So now this left hand meets this left hand. So what do you see now? Look at it carefully. This and this is same, right? Everything left hand side of like the less than sign. The only thing is different is this. But what does this mean? If this and this is the same, then technically this means that this epsilon, this delta over here has to be equal to this one. See, look there, same. So now I can write this. It'll always be like this no matter what when you get to this point. S is equals to epsilon over 4. Because think about it, this and this is the same. So like this has to be same, right? It'll always be this. You just have to memorize this, the process. Now, when I got this, right, I want you to basically, now that we're done with this equation, go to this equation and replace S with epsilon over 4. And I want to see what it gets, right? So x minus 3, it's less than, now change S to epsilon over 4. Now if you look what I'm doing, it's actually very, very cheeky, but I'm basically now rewriting the last step and I'm going to the first step over here. See? Exact same. So now I want to get rid of basically I want this now equation to be the same of that. In the first one, we're basically proving that this is the same as this. Now we're proving this is the same as that. So we have to get E by itself. So obviously we'll get rid of the 4. So that's 4 x minus 3 less than epsilon. Perfect. Somehow, look at this now. We're almost there. But how do we get now this? Well, take the 4 in. You're doing the exact same here in reverse. So it's 4x minus 12. I'm just multiplying. And now, how do you get this to this? Well, just remove the minus 1 and minus 11 from minus 12. Because you can rewrite minus 12 as minus 1 minus 11, right? I mean, look how we went from here to here. So just rewrite that. So 4x minus 11 minus 1, because that's minus 12, is less than epsilon. So now put the brackets there. And there we go. We copy it down and this equals to this. Therefore, our proof is done. So to summarize, somehow make this the same as this. After you do that, somehow make this the same as this. So basically you're saying this is true, then that is true, then that is true, then that is true. So that's how I did it. Remember, it's just memorizing. You just have to memorize this formula. Also, I told you, just say S is greater than 0 and E is greater than 0. Not S, this is delta. So yeah, then you're done with the proof.